Hello and welcome back to Clarkenomics. In this video, I'm going to talk about shifting a production possibilities frontier. So let's first go back to the one that we had already created in the previous video, where we had a country called Fruitopia that only produced two goods, lemonade on the y-axis, limeade on the x-axis, and had to decide what combination they wanted to produce. And so we came up with 6 discrete different possibilities here on this curve, but line, curve, whatever, but said that there are also many other possible combinations in between these, but that all of them are equally efficient production options. What that means is they're using their resources to their max potential. That, by the way, is why we call this a production possibilities frontier. A frontier is a limit. So this is the limit on how much they can produce. That's why this point out here, G, was impossible, because if this line represents the limit, they cannot at this time go past the limit. And this underutilizing point in here means they're not using all their resources to their fullest potential. They haven't met their frontier. They could be doing more. But in this video, we're going to look at what happens when things change over time. For instance, point G might only be impossible right now. It doesn't mean it's going to be impossible forever. So let's look at a situation where we shift one of these production possibilities frontiers. For instance, we've got this graph. Now, before this looks too confusing, this is actually the same graph as before, only the scale of the axis, both axes, has actually changed. So if you look at the data points in the table, they're all the same as they were before, right? For lemonade, it's 10, 8, 6, 4, 2, 0, and limeade is 0, 1, 2, 3, 4, 5. And we've got all those same points plotted here. I just had to make a little bit of room because things are going to get a little different. So let's imagine that a new water source is discovered in Fruitopia. And since water is one of the ingredients used to make both lemonade and limeade, now that they have more water, which when we're looking at the factors of production we would call land, now that they have access to more land, in this case water, they can produce not just more lemonade, not just more limeade, but both things they can produce more of now. So we're going to edit the table and put a new curve on here. Look carefully at the screen, because here comes the change. So what's happened in our table? Well, a few things. In the production option, I kept the letters, but I just put little subscripts there. So A became A2, B became B2, and so on and so forth. And I took each of the numbers and I doubled them, because now they can make twice as much, let's say, of both things, because of this new discovery of a water source. And so, same as before, this is the old line right here from our old table. Based on these values, though, we can now plot ourselves a new line. So for instance, A2, not A, there's A. A2 is up here. A2 is 20 billion gallons of lemonade, and if they produce 20 billion gallons of lemonade, they cannot produce any limeade. Or they could decide to produce 10 billion gallons of limeade, but if they do that, they're not producing any lemonade. So what we've done, and you can see the arrow here, is we've just taken this and we've shifted it outwards. And because we have doubled both sets of values here, these two lines are parallel to each other. Now, the reason why we're looking at this is because, yeah, the line shifted out, like whatever, that's fine. But the point G, which used to be impossible originally, right? Because this was your original frontier, you couldn't produce at any point past this. Well, the frontier shifted outwards to here. So if we get rid of that old one, what used to be an impossible point of production would now, in this new situation, be a point of underutilization. Not only is G achievable, it's actually an inefficient point of production now. So that's something that could shift the production possibilities curve outwards. They could produce more of both things. So talking about, why does this happen? Why does a PPF shift outward? It could be a bunch of stuff. Maybe there's access to more land, more labor, more physical capital through discovery. The United States just, a decade ago discovered these massive deposits of shale gas beneath the ground. That's access to more land. In times of, the Romans, you want more land or labor or physical capital, go invade a place and take it over and take their stuff. So there's lots of ways where a country could acquire more of these things. But it doesn't necessarily mean that they have to acquire more. Oh, and by the way, greater immigration could also lead to more labor as well, right? If you've got more people, you've got more workers. So there you go. But it's not just about how much of these things you have, it's about how you use them, right? And so let's say human capital increases. Maybe the government decides to invest more in education, more in retraining workers. If laborers have more capital, then they're going to be more productive workers. And so the same amount of laborers will be able to produce more lemonade and more limeade, if we're going back to our Fruitopia example. Or maybe it's some other kind of innovation. Entrepreneurship, entrepreneurs competing, business owners competing against each other forces each one of them to try to do things in better new ways so that they can survive. And that innovation often takes the form these days of technology. So maybe a new technology comes along that makes workers better. It increases their productivity. Maybe they spent time doing things by hand, and some new technology, some new machine is invented that makes that job no longer needed to be done by hand, but it can be done a lot faster. Or maybe it's just something that otherwise reduces the cost of production. We used to need to spend this money to do this. Now, due to some change in technology, we can do this for a lot cheaper. These things happen. These aren't hypotheticals, for us. These happen all the time in the United States. So these types of things, if they were things that equally benefited both of the things produced, like for instance, the increase in the water source, you'd see the PPF shift out in a parallel way. But let's imagine we've got a different situation. We've got something like this. There's the original graph, no change from before. Again, the axes change, so it looks a little different, but it's the same as the original table and the original line. Let's imagine that in Fruitopia, they discover or they develop new disease-resistant limes. So they used to lose a bunch of their lime crop every year because of disease. Now they develop a new type of lime that is more hardy, more resistant to disease. So they can produce more limeade, but it doesn't really help out with the lemonade because whatever they developed, genetically doesn't apply to lemons, let's say. It only benefits their production of limeade. Can you predict what would happen to this PPF if they invent something that only makes it easier to produce one of these two things? For instance, makes it easier to produce limeade or cheaper to produce limeade. In other words, they can produce more limeade. So it would look like this. So I changed the table again. This time, the lemonade values stay the same as what they originally were, but all of the limeade values actually double. And if you do that, you come up with this orange line right here. Yes, the PPF shifts outwards just like it did before, but you'll notice that it is not a parallel shift. It only shifts outwards kind of like it's rotating around point A here. And let's talk about why that is. Point A, or A2, they're actually the same point overlapping. At that point, you're producing 10 billion gallons of lemonade and no gallons of limeade. Well, if they develop this brand new, disease-resistant lime, but they're not making any limeade, that's not going to change a darn thing, right? They're only producing lemonade. Who cares about these new disease-resistant limes? So in other words, nothing changes here because they're not producing any limeade. But as you move to point B or to point C and so on and so forth, you'll notice that it shifts outwards by more and more and more, because what that means is as we move down from A to B, C, and so on and so forth, we're producing more limeade at each of those points until you get to point F where they're only producing limeade and no lemonade. And that's where you're going to see the greatest increase in the production possibilities because all of their production is going towards limeade and they have this great new disease-resistant lime. In fact, you'll notice it went from 5, which was the original, to 10 because it doubled. And so the more limeade you produce, the more beneficial this new technology, if you'd like to call it technology, actually is. Up here at point A, it has no effect, but that effect becomes bigger as you move down the line. So there's a couple different ways that a production possibilities curve could shift. So some big reminders here. One, everything is scarce. Nothing is infinite. Everything is finite. Because everything is scarce, scarcity forces us all to make trade-offs. We can't have it all, so we are faced with alternatives and we have to make choices. But when we choose things, we create choices, but we unfortunately also create opportunity costs. Every time you choose to do more of one thing, you have to do less of something else. You want to make more lemonade, you have to give up more limeade. And so, to wrap things up, economics is the study of how humans make choices to cope with scarcity. How do humans make these trade offs? And so, thank you for watching. I hope you've learned a lot from this segment, and have a great day.